everyone, and welcome to the next video in our Properties of Geometric Figures series. This video is going to be all about quadrilaterals. So quadrilaterals are an interesting beast in mathematics. There are a whole bunch of different types of quadrilaterals. You can have regular quadrilaterals, you can have irregular quadrilaterals, but the thing that they all have in common is that they have 4 straight sides. Okay, that is a quadrilateral. That's the quad part of quadrilateral is 4. Okay, now they do include a bunch of special shapes, which is what we are going to explore in this video. And we're going to go through the evolution of how we get to those different special shapes and what makes them special. Okay, now we can start our special shapes with just a straight random quadrilateral or a straight random 4-sided shape. So just a random 4-sided shape. Now mine's not very straight. It would be better if I used a ruler. Now, this is a straight quadrilateral. And the main feature on this quadrilateral is that it has 4 sides. That's its main feature. It's an irregular quadrilateral. None of the sides are equal. None of the angles are equal, but there are 4 of them. Now you can see we've got some arrows leading away from our quadrilateral here. One's going up. Now, to go up, I'm actually going to add a new feature, and I'm going to give this feature as a pair of parallel sides. I'm just going to fix up my word there. So I'm now going to add a pair of parallel sides, just one single pair, to create my new shape. And the new shape that I'm going to end up with is a trapezium. So here's my trapezium. You can see the top and the bottom line for the trapezium are both parallel, and the other 2 sides are just fairly random. Okay, so this one is the trapezium. And you may even see it written as a trapezoid, but trapezium is the way to describe it for us. And so it has 4 sides plus the pair of parallel sides. Now if I keep going along that line and I leave the trapezium down, I'm going to add another pair of parallel sides. So now I've got a second pair of parallel sides, and that's going to give me the parallelogram. So that's where both sets of sides, both pairs of sides are parallel, indicated by the 2 sets of arrows there. Now moving on from that one, going back up towards the top, our new feature, I should probably label my parallelogram. So our new feature going across the top is a 90-degree angle. So now that I've added that 90-degree angle, what happens is one angle becomes 90 degrees, and just because of the nature of those lines being all parallel, all of my angles will now be 90 degrees. And what that gives me is the rectangle. And again, using a ruler is often best with this. So there's my 90-degree angle, and there are my parallel sides. So that gives me my rectangle. And then we'll leave the last one for now. Let's go back to the beginning. And instead of going up to the pair of parallel sides, what I'm going to do down the bottom is I'm going to add a couple of pairs of equal sides. Now what's that's going to do, so 2 pairs of equal sides. So what that's going to give me is, here's a pair of equal sides indicated by the little dash. So parallel is indicated by the arrows, little dash indicates equality. I'm going to put 2 slightly longer ones down here and give it 2 dashes to say that they're equal to each other, but not the ones at the top. Now I actually need this to be a little bit bigger, so I'm going to redraw this one. So there we go, my 2 equal ones there. And then those are 2 equal ones there. So this shape is officially known as a kite. I might actually put that label at the top. So this one's a kite now, and you can see that there's the 2 pairs of equal sides. Moving back up, the arrows now back up towards the parallelogram. What we're actually going to do now, instead of just being 2 pairs of equal sides, they are now opposite sides being equal. So opposite sides equal. And you can see that these special properties for each shape are building as we're going along. Okay? So parallelogram, the opposite sides are equal. So let's just add those little dashes in. Okay, so that gives us that property. So we're moving along the line. We've given parallel sides, we've given equal sides, 2 pairs of parallel sides, opposite sides being equal to get our shapes. And then moving on to the next stage, heading down again, we're going to make all of our sides equal. So up we made our angles a different size. We made them 90 degrees. We're going to go down and we're just going to make all of our sides equal. We're not going to change our angles. Just going to make our sides equal. So I'll write that in. So all sides equal. Grab the different coloured pen again, and then my parallel sides. It's not quite right there. Let's give that one more go. See, I should be using a ruler. So you can see my sides here, they are still parallel. I still have my 2 pairs of parallel sides, just like the parallelogram, but now all of my sides are equal. So if I put the little dash in indicating all of my sides being equal, and hopefully you have guessed the name of this particular shape, this one is a rhombus. Alright, it is a rhombus. So now we're going to bring all of those properties together, because our last shape is a very, very special shape. Okay, our last shape, well, it's going to have all of the sides being equal. It's going to have pairs of opposite sides being parallel. It's going to have 90-degree angles. It's going to have a couple of other features too that we're going to talk about in a minute. But our last shape has all the sides equal. It has 90-degree angles. It has parallel pairs. And hopefully you have guessed this shape's name. This shape happens to be the square. So the square is a really special quadrilateral shape. Now there's a couple of other little bits and pieces that we need to go back and fill in, namely on our kite, our rhombus, and our square. So let's go in and have a look at those shapes, shall we? Let's start here. Here we go. Let's pop these in orange. We can put in diagonals here for the kite. So we can go from the top little corner and then down to the bottom, and then the two side vertices. And what we know about these particular diagonals is they will meet at 90 degrees. Okay, so these diagonals meet at 90 degrees. Okay, the other thing about these diagonals is they actually bisect each other. And what that means is that one side, so that side is the same size as that side, and that's going to happen. Okay, so one bisects the other is what I should be writing down. Let me just fix that. So one diagonal bisects the other. Okay, now the rhombus does something very, very similar. So let's pop in an arrow to join those two shapes. Okay, and this is a note about the diagonals. Okay, so our kite meets at 90 degrees, the one diagonal bisects the other. The rhombus, very, very similar. We can put that diagonal in. We can put this diagonal in. They're still meeting at 90 degrees. Okay, so the diagonal meet at 90 degrees. Okay, this time, however, they bisect each other. So this part of the diagonal is equal to this part of the diagonal, is equal to that part of the diagonal. Well, it's not actually equal to that part of the diagonal. These two are the same. So let's give those 2 dashes. And then the other one's 3, because while they are bisecting each other, the 2 dash ones are different to the other dash ones. So let's give these ones 3 dashes. So they do bisect each other and they do become equal to each other. Okay, so bisect each other. Okay, so cuts them down the middle. Now that all leads back up to our square. All the way back up to our square. Right, so more on the diagonals over here. Let's bring our square into play. And we can put our diagonals in. They do meet at 90 degrees. So our diagonals meet at 90 degrees. And the other thing here is that these ones actually do bisect each other equally. So all 4 parts of those diagonals are the same size. So that one, that one, that one, and that one are all the same size. So these guys bisect each other equally. Alright, and that is our evolution of quadrilaterals. So that's the whole diagram. Now that's going to be it for this video, and in the next video we're going to hit up some examples. See you there.